Hello, my name is Rajdeep Singh. Let us study a topic of physics, law of gravitational attraction. So we consider two masses m1 and m2 which are placed at a distance r and they have a gravitational force of attraction Fg. So these are point masses that are regular bodies and the size of these should be very less than as a distance compared to them. So mass should be very less than the distance. So the gravitational force depend on two things. First of all, mass, and second, the distance between them. So masses, the product of mass will be high, so gravitational force will be high. If the distance between them is high, the force of gravitation will be less because attraction decreases when we move objects far apart. As we know, if we move far apart the objects, repulsion increases. So to increase attraction, the distance between them should be less. So it is inversely proportional to the square between them. So we can write Fg is directly inversely proportional to r square and directly proportional to m1 and m2. Now this is called inverse square law. Now this law is given by Newton, and this Newton's law is called law of gravitational attraction, and we also say that this is an inverse square law. So inverse square law states that the force of attraction between is them is inversely proportional to the square of distance between them and is directly proportional to the product of mass. So we can say it is directly proportional to product of mass and inversely proportional to r square. So the value of force of gravity is inversely proportional to r square and directly proportional to m1 and m2. Now we say that when we remove proportionality constant, we write a constant that is called universal gravitation constant represented by g. So its value is same everywhere, and we if we take an object in another planet, its value will be same, that is equal to 6.67 into 10 raised to power minus 11 newton meter square per kg square. Here m1 and m2 are mass and r is the distance between the two forces. Now moving on to the next concept, gravitational force. Gravitational force is the weakest force among the all forces, so it is the weakest force. So in nature there is the strongest force that exists is nuclear force, and then electrostatic force, and then gravitational force. So very less is the gravitational force that exists in nature. So due to existence of gravitational force, it is the weakest force. Now what is nuclear force? So nuclear force dominates between an atom. So in atom there is a nucleus which contains proton and neutron, and electron is revolving around the orbit. So electron and nucleus exhibit a strong nuclear attraction. So most strong nuclear force that exists between uh, electron and nucleus is called nuclear force, or you can say nuclear attraction. So this nuclear force or nuclear attraction is used in atom bombs, or we can say nuclear bombs, which can destroy a large area. So here it is written most strongest force existing in nature earth is our nuclear force. So, okay, so due to existence of nuclear force, we are making an atom bomb and nuclear bomb which can destroy a large area. So this nuclear force exists in this way. Now, what is electrostatic force? So, electrostatic force depends on a mass of charges. So, when two charges kept at a distance r and they are attracting a force F1 and F2, so we can say F1 is directly proportional to Q1 Q2 divided by r square. So, this is electrostatic charge particle. Now, moving to the next concept. So, now we take M1 and M2 two masses. M1 and M2 are exhibiting a gravitational force Fg and Fg, and there are we have given acceleration a1 from here and a2 from here. Now this force on 1 due to 2 is minus of 1 force on 1 due to 2. This follows Newton's third law. We can see action reaction pair, which state that every action has an equal and opposite reaction. So here force on 1 is due to 2 and 2 is due to 1, and it is of minus. Now m1 is, if we take m1 is greater than m2, so we can see a1 is equal to f by m1, and if m1 is greater than m2, so it's very large, so acceleration will be 0, a1 will be 0. Now a2 f by m2, we know that f is equal to ma. From here we have written this formula. Now a2 is equal to f by m2. Now m2 is very less from this condition, so we can say m2 is less, so this will be large. So this is large, so we can say a1 and a2 are not equal. Now there are some general points related to gravitational chapter that I have written. The gravitational force is independent of the medium. So if you change any medium, gravitational force will not change. It will always be same everywhere. If you take in water, air, or any vacuum medium, the gravitational force will always be same in every condition. So this point states that only. Now the gravitational force always acts along a line joining two forces. For example, if I take mass m1 and if I take m2, so this line axis joining it always acts. So we can say it is an line joining force. Now third point is gravitational force is a conservative force. Conservative means it only depends on the path followed by it. Okay, it didn't depend on the condition, so it is a conservative force. Now let us do an example question for it. So if question is if the distance between two masses is doubled, so gravitational attraction between them. So it is saying that if distance between the two masses is doubled. Okay, so let us take example. So let us take two masses m1 and m2. So if their distance is doubled, so let us take our initial distance to be r, and now it is double. So it is saying that what will happen. So we know that the gravitational formula is Fg is equal to gm1 m2 divided by r square. So Fg is inversely proportional to r square. So when we increase the distance between them, the gravitational force will be reduced. So if we increasing the distance, so first of all it is r, and now so we can write from here Fg is equal to inversely proportional to r square. Now when the distance is 2r, so Fg becomes 1 by 4r square. So we can say it is reduced by a quarter. So answer will be it is reduced by a quarter. So we can say the gravitational force is reduced. Why it is reduced? Because we are following this formula. Fg is inversely proportional to r square. So is inversely proportional to r square. So initially it was r. So we can write Fg is inversely proportional to r square. Okay. Now when it is 2r, so Fg will be 1 by 2r ka whole square. So it will be Fg is inversely proportional to 4r square. So it is reduced by 4 times, or we can say it is reduced by quarter times. So this is the solution to this particular part. Now moving on to the next part. So now moving on to the next question. Question says that two spheres of masses m, that is small m and capital M, that are situated in air. So and the gravitational force between them is F. So when m and m are situated in air, so their force is F. Now the space around the masses is now filled with a liquid of specific gravity 3. So specific gravity is 3 now. So the force will be. So I have told now that m and m are two masses that are given to us, and they are placed at a distance we can say r. Now these exert a force F and F respectively. Now in air the force is F. Okay. So it is saying that a liquid, okay, of specific gravity 3, so the force will be. So I have told you right now that the gravitational force didn't depend on the we can say the liquid medium. Okay, it didn't depend on the liquid medium, on medium, so force will remain same. So if we take F dash, so it will be F only. Here in air the force is F. Okay. Now next new force, when we take when we took two spheres on a liquid of specific gravity 3, the force will be same F. The reason the the gravitational force remain same if medium is changed. If medium is changed, so gravitational force always depends on the medium between them. So if medium is changed, gravitational force will not change. Okay, so gravitational force will remain same. So this is the reason to this particular question. So this is the concept. So I hope you are now learned the concept of law of gravitational attraction. I have done the numerical part also. So thank you very much, student. Thank you.